All right. Hi, everybody. Hi. Yeah, good stuff. Welcome. Welcome. How's the show going so far? Getting your steps in? I have. It's going to be great. I'm really glad you're all here. We've got very little time, though, so I just wanted to kind of do a quick show of hands. Who's using Spring Boot 2? Spring Boot 2.x. Okay. And who's using Spring Boot 3? Okay, good stuff. So today, we're just going to talk about that release, that generation. I am of the opinion that this is the single most important release in the history of Spring. And this year, of course, we celebrate 20 years of something called Spring Framework and 10 years of something called Spring Boot. And by the way, I just realized the lights are not great. I wonder, how do you turn the, whatever. Anyway, have you seen the Spring1.io history of Spring? So you go here, the Spring1.io /history of history, history of Spring with dashes between the words. And then just scroll right, and I'll let you do that yourself. It's awesome. It's really, really good. I'm not gonna do the whole thing, but yeah, take a photo of that for later, not now, because it'll take a lot of precious time that you are gonna need to follow along with this. You can go a little faster if you use the space bar, like that. It's, we're in the clouds, so there you go, Spring Cloud, right? All right, going back down, water, skipper. There we go, right? Very good. And so then, of course, this is like the most amazing ad for what we're doing right now. Spring 1, our first one back in person. It's so good to see you all here. But anyway, I say all that to say, Spring Boot 3.0, that generation, Spring Boot 3.x, is in my estimation the single most important release of Spring because it opens up entirely new paradigms. It's not just a cleaner, simpler way to do things that we could already do. There's now new opportunities for developers, and we're gonna just see, everything. We're just gonna, the goal here is to go as fast as possible in all the ways that matter, to be as productive as possible in all the ways that matter, and to do so effectively, productively. So, as always, we're gonna build some new software by going to my second favorite place on the internet. My first favorite place on the internet, of course, is production. I love production. You too should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It's better than Disneyland. But if you've never been there, you can begin your journey here, as always, at start.spring.io. So what we're going to do is build an application. Friends, we have some choices to make. Obviously, these days, the default build tool is Gradle. So my New Year's resolution was to learn Gradle and to lose some weight. And well, anyway, my Gradle's going great. It's going well. I'm definitely learning Gradle. And then we have a choice of what version of the framework to use. I'm going to use the latest and greatest because why not? Then we have a choice of what we want to name our service. And friends, I'm going to call this Service. And the reason I'm going to call it Service is because I'm great with names. Just amazing, brilliant with names. I get that from my father. My father was also great with names. We had a small, tiny, white dog as a child. And so my father named him White Dog. Now that dog disappeared after like 10 years. I don't know what happened to him. He disappeared, maybe he got a job, I don't know. But then another small white dog appeared knocking on our door. So my father named him 2. And anyway, I get that from my dad. I'm great with names, just like him. So I'm gonna call this Service. My mom, by the way, she always tells me, she says, you're very lucky that I named you. And I think that's a good point. It's a very good point. So, friends, we obviously have a choice down here of what version of Java to use. Obviously, to use Spring Boot 3.x, you must use Java 17 or later. So while we have these other checkboxes here, these are not valid checkboxes. You must use Java 17 or later. And by the way, Java 21 is coming out in less than a month on September 19th. So we've got Java 17, I'm using that today, but next month you better bet I'm gonna be using the new stuff, right? There's no reason to be using this legacy, creakingly old, ancient, deprecated, long since past irrelevant version of Java at Java 17. It's a bad idea. So these other checkboxes, these are just for the memes, just for the lulz, just to find out who makes terrible life decisions. You should never select these, ever, in any context. They're completely inappropriate. Java 17 is great for now. Certainly a far sight better than Java 8. Java 8 is technically slower inferior in every way. It's inferior, it's less robust, less syntax rich, less capable, less performant, less secure, less everything. It's technically inferior in every way. It's also morally inferior. You won't like the look of sadness and shame in your children's eyes when they find out you're using Java 8 in production. Don't do this. Be the change you want to see in the world. Do the right thing. Use at least Java 17 or later. And judging purely by the version number alone, I think we can all agree that Java 17 is more than twice as good as Java 8. Hopefully I've satisfied you that there is no reason to be using these older versions ever. Now, with that done, let's make some selections. We're going to bring in the Spring Boot actuator. We're going to bring in Postgres. We're going to bring in the data JDBC support. We're going to bring in dev tools and the web support. There's dev tools. We're going to bring in the GraalVM-native image support. We're going to bring in the Testcontainers support. Let's see, what else do we want? We've got the actuator, Postgres, Spring Data JDBC, web support, dev tools, GraalVM, Testcontainers. I think that's everything. That looks like everything. Okay, I'm going to hit generate. I'm going to open this up in our IDE. I'm happy with those selections, so I'll go do that in my IDE. It doesn't matter what IDE you use, so long as it supports the version of Java and the build tool that you're using, which in my case, this one very well does. We're going to let that load. Take your time, really, nobody's waiting. Look at that, okay, good. So here's our service. I'm going to make that font a wee bit bigger. Can you all see that in the back? Okay, good. So it's a brand new application, and what I'm going to do is I'm going to build an application that writes to the database. So of course, I'm going to create I'm going to build an application. It's going to talk to a database. I'm going to build a record, okay, like this. I'm going to say, this is my entity. Come on. You need to be, okay, there you go. Entity, string name, got a record, and of course I need to give it an ID like that. And I love this feature. I love this so much, okay? Love it. I'm a huge records fan. So I'll use that, and then I'm going to create a repository here. Customer repository, voila, like so. Repository extends list of CRUD repository, managing entities of type customer whose primary key is of type integer. Very good. So now I've got the basics of my data access layer, but I need to actually have a database. And friends, I'm all about that git clone run lifestyle. I want to be able to take this code and immediately start working on it. And I talked in the keynote about the dreaded 500 easy steps to production, something I want to avoid at all costs. And so to that end, we have a nice new feature in Spring Boot 3.1 that supports test containers and so on. So I'm going to go here. I've got another public static void main. You notice that this is public static void main, but it's in the test code. It's in the test module here, right? And this class is in turn just a regular @configuration class, right? This is basically just @configuration. And it brings with it the ability to register components that are available only during development. So I run this class during development, and extra beans that I need only during development are present, okay? So what this is going to do is it's going to create a bean, it's going to use the Testcontainers API, it's going to stand up a new Docker instance containing Postgres, in this case the Postgres latest version, and there's another sort of corresponding feature here, which is that Spring Boot will look at this bean definition and it'll identify that it's a service connection, and it'll automatically hydrate the Spring data source URL and Spring data source username and Spring data source password. It'll basically arrive at those values for you. Right? It doesn't actually use those properties anymore for that, but it does basically look at the database in the Docker image and get you the connection details for you. So I don't have to specify that. And then I'm going to use dev tools. Now dev tools are great. Dev tools allow me to automatically make changes to my code, and then because Java is pretty slow to start up, but Spring is very quick, the idea is we keep the JVM warm and we just make changes as we're going, and it very, very quickly cycles the Spring application context, preserving the JVM, the running JVM process. The result is that you get to make changes lightning quick, okay? But in order to use dev tools, you trigger a recompile, right? I'm gonna do a rebuild. Command Shift F9 on my Mac. It's similar on Windows. I imagine it's Control Shift F9 or something like that. Okay, so I'm gonna use that, and it's great, but remember, it's going to recreate the Spring application context anew for every little change, right? Well, Spring is very fast, but you know what's not fast? Postgres. That's okay. It's a whole database. It's fine if it takes a little bit of time, but nonetheless, if this is going to get recreated on every single restart, that's going to cause some delay. So what I'm going to do is I'm going to use a new annotation in the DevTools library here. I'm going to say test implementation like that. I'll re-import that, Command-Shift-I, and then I'll use this restart scope annotation, okay? That'll tell Spring Boot to not DevTools. It'll tell DevTools to not recreate this bean on every single recreation, okay? So we've got that, we've got our data entity, we've got our data access layer, we've got all this stuff, but we need some actual data, don't we? So let's go here to the actual service application, and we want to set up some schema and some data and all that stuff. So I'll go to my main folder, source main resources. We're going to say schema.sql. I'll create a table. If not exists, customer, ID, serial, primary key, name varchar 255, not null. Okay, there's my schema. I also want to create some sample data. I'll just put a few people on the Spring team in here. I'll say delete from customer, and I'll say insert into customer. Just some names of random people on the Spring team, okay? Hi, I'm Josh, I'm on the Spring team, of course. Got Rob, of course. We've got, who else do we have? We've got the one, the only, the amazing Madura, and we've got Yushin and Olga, and Dr. Sire, of course, and nope, don't do that wrong, okay? Jurgen, and then Stefan. Accents are fun. Good, so what is that? It's 8 records, right? So if I divide it by 2 and then 2 again, it's still 2. It's great, I love 8. I'm a fan, okay? Good stuff. The last thing I want to do is I want to tell Spring Boot to automatically initialize the database, always, as opposed to just when I have an embedded device, because even though Spring Boot is now starting up via the Testcontainers API, the Docker image for me, it's not embedded per se. It's still a network process away, okay? Okay, so I've got my application. Let's go ahead and run this for the first time. And this is going to take a long time, right? The first time it has to launch that Docker image, which is great, but we do have to wait. And that's fine, but this is the only time we're going to really have to worry about that. Let's see. Insert into customer names. Oh, names. What did I do there? Scheme data. Uh-oh. Uh-oh. Yeah. Very awkward. Okay. Take 3. This time for all the money. Here we go. There you go. See, it looks like it's happy. So it's starting the database. You can see Testcontainers is spinning up. It has identified the connection, and it's created a container and all that stuff. It took 3 seconds, which is an excruciating amount of time. But again, I won't worry about that anymore. Okay. So here we go. We have our application. I guess what I want to do is I want to build a simple controller. So I'll build a controller like this. I'll say @controller class customer controller. And we'll inject the repository that we just created. It's a private final customer repository, right? And I'm just going to inject that into the constructor. And then we're going to create git mappings, customers, collection, okay, collection, customer, customers, okay? And we're going to say return this.repository.findAll. There's that. And that's fine. I like this a lot. Let's go ahead and do a Command-Shift F9. That'll trigger the restart, right? It's just recompile the code, and voila. So once it recompiled, it took 0.29 seconds to run. So more than 10 times faster than doing the full restart, which is what we want. That's a good thing, TM, okay? So now I've got this endpoint. Let's see if that worked, okay? Customers, what did I do? Check your view. Oh, silly. Command-Shift F9, go here. Did it work? There we go. There's our data, okay? So now we've got our data, it's working, it's fine. Now I want to create another endpoint here. I'll say git mapping, customers, name, collection of customers by name, path variable, string name, okay? Return this.repository.find by name. Okay, pass this in, pass that in. There we go. So this method very clearly does not exist. So I'm going to let the IDE do the walking, take that ChatGPT, and I'll just create the repository automatically. So I can now say find by name Josh. Et voila, it worked. Okay, great. So now we have a simple HTTP controller. We have data in the database. We're moving fast. Great. We're ready to go to production. Surely. No, right? Obviously not. Any idiot can build an HTTP endpoint. They can even do that in PHP. This is not impressive. We need to move on. We need to think about how we make this code worthy of production. And to that end, my friends, there are a few things that we need to care about. First and foremost, how do we make this observable? Now that means a lot of things to a lot of people, but basically, given the outputs of this system, of the application in production, how can I understand what it's doing? And there are 3 sort of things that we look at: logs, metrics, and traces, okay? And traditionally, we used micrometer to do the metrics, okay? So this is the application observability facade that we created before we created Spring Boot 2. Think of it like SLF4J, but for observability. It has integrations with all manner of different observability systems, time series databases and distributed tracing systems like Wavefront and Stackdriver Trace and OpenTelemetry and Prometheus and OpenZipkin and so on. All very good. So that used to be like this. It used to be we had Micrometer.io, and then we'd have Spring Framework. Let me make that bigger, friends. Sorry about that. And then we had Spring Boot that depended on Spring Framework, which depended on Micrometer. And then we had Spring Cloud, and then we had Spring Cloud Sleuth. So this is for distributed tracing, and this is for metrics. And the problem was that this is very asymmetrical. So this is the old Boot 2 world, right? Since then, we've gotten rid of that, and we've pushed metrics and tracing down into Micrometer. So now we have one unified abstraction at the same level of abstraction to handle both. So let's use both of those. Let's use that. I'm going to use a new API that was introduced here called an observation. So you say observation, create not started, by name, and I'm going to inject a observation registry, right? Here we are, observation registry. Whoa. Okay. Inject that into the constructor, voila. And we'll say this.registry, and then I'm going to create a supplier in which I'm going to just make this call here. I'll say voila, okay. So now what I've done is here I'm doing distributed tracing, and here I'm creating a metric, okay? This is creating a new metric called by name, and in this context, if I were to make a call to another distributed system, another service, things like JDBC and JMS, or another HTTP endpoint, or Kafka, or RabbitMQ, or whatever, then I could automatically either incept distributed tracing headers or propagate distributed tracing headers, okay? So that'll automatically happen if I wanted to. And I want to see these metrics. So what I'm going to do is I'm going to use the Spring Boot actuator, which is on the class path here. And in order to use the actuator, I need to enable, the actuator endpoints. I'll show all the health details. I'll show the Kubernetes probes. I'll make my Command-Shift F9, and I'll go here, localhost actuator, et voila. Okay, there's my managed HTTP endpoints that give me information about the application, like the health endpoint, info, environment, config props, loggers, all this good stuff. What I care about, of course, is the metrics. And you can see here, my friends, that we don't have any metric for by name just yet. So let's fix that, shall we? We'll go here, we'll say while, oh dear, come on. While true, do curl HTTP localhost 8080/customers. Done. We're just going to let that run for a second. Good, thank you. Now, if you go here, what is it called? By name? Oh, I did the wrong one. I did the all of them. I want Josh. Okay, there we go. Let that run. Okay, now go up here. There's by name. Okay, go there, and now you can see I made about 145 requests in whatever time I ran, and that's the total time it took for all of them combined, and so on. Okay. Nice. Now, of course, this is just in my little HTTP endpoint there, but I could use the actuator integration with Prometheus and Graphite and all that stuff to see that stuff visualized, to have a single pane of glass that I can give to understand what the system is doing and when and how and at what speed and what latency and so on. Okay, well, so now we've got observability, we've got test containers, we've got dev tools, we've got our stock standard HTTP and JDBC sort of data access tier. What now? Now it's time to package this thing for production, right? Although, we could do one more thing. One more thing. I want to do one more thing that we could only do at this conference. It wasn't possible before this conference. I mean, I suppose it would have been. I probably could have, but it was more fun to keep it. So one more thing. One more thing is I want to, I don't know, maybe a little AI. That could be good, right? What could go wrong? It's a closed world system. It's going to be fine. So I have this file here. Slides, here we go. So we're going to go ahead. Have you seen the new Spring AI project? Have you heard about it? There's a lot. There's a great session by the good, the great, the amazing, the inimitable Dr. Mark Pollock later today, like 3 o'clock-ish. Let me check here. 3:45 to 4:30. And it's in level 4, Lando 4206, so just 4 doors down, I think. Aren't we 4202? I think we are. So you should go to that to get the how and the why and everything else, but just for our purposes, let's just skip a little. We're going to bring in the snapshot dependencies, because we can. And repositories, very good, thank you. And we're going to bring in this dependency of a starter, voila, okay? And that's going to give us a AI client. Now I happen to have, on my environment variables, I have a property for Spring AI Oh, is it still loading? Oh, come on, do the thing. We talked about this. Get her done. Hurry up. What is building mode? What's the mode you're not in? What's the other mode that you're in when you're not in building mode?
Indexing.
Yeah, indexing mode, right. And then it has to build, that's a building of an index. This is abhorrent. Seriously, what are you doing? Well, anyway, does it let me have the types? So, we can say private final AI, well, you know what, I'll do another one. Let's do one more controller. At controller class, jokes controller, private final, hello, AI client. Oh, did it not find it? That would be hysterical. I don't know, that doesn't seem great. It's still like thinking. Oh, there you go, download more, look at that. It's impressive. Okay. It's going great. Really great. Okay. There. Please, there you go, good. So we got that, we're gonna inject that. I'm just gonna create one more endpoint. Let's say jokes, string. So we're gonna say return this.ai client dot generate, tell me a joke about seasons. Okay, there we go. And in order to make that work, you need a property. I happen to already have that property. I've set the, you can either set the Azure API key or the OpenAI API key, and I've already got that as an environment variable. I'm not about to leak that to y'all, so, you know, sadness. Okay, so basically that's already set. If all goes to plan, let's just run this one more time. Oop, I just restarted it for no reason. Oh, I forgot to do the Command Shift F9. No, it's fine. We're gonna recover. Stop this. Close this. Close that. Because remember, I changed the class path, so you do need to reload for that. No, wrong one, please. Test service application. Okay, please do the thing we talked about. Okay. Remember, 3 seconds for a full restart. Goody. Localhost, let's see. Jokes. Oh, you're kidding. It's the REST controller, isn't it? Yeah. Response buddy. It's fine. I walked right into that. Thinking, talking to the cloud. There you go. Why did the Scarecrow win an award? Because he was outstanding in his field during every season. Oh. I should just leave. My days are numbered. Anyway, that's nice, huh? So now we've got this application. I think it's time to think about how to package this thing for production. And my friends, what I want to do is I want to package it in such a way that it's faster, more scalable, more performant, more efficient, more everything. And in that vein, in that sort of sphere of thinking, I want to talk about how to make my application more efficient. But before I do that, I want to establish that I think that Java is already super, super efficient, right? And I think this is a point best made by this blog from 2018, before COVID, or BC. And it asks the question, which programming languages use the least electricity? It's a great blog. It's a blog based on a paper, actually. And the blog looks at a lot of different things here. And my favorite thing is this right here. This is a normalized global results for energy, time, and memory, okay? So a couple of interesting things. First of all, C is the most efficient. And what I mean by that is for machines. It's the most, not for people, definitely not for people. For machines, it is the most efficient way to write code. Then you've got Rust doing quite well, zero cost abstractions, good stuff. C++, tooey, disgusting, moving on. Then you've got Ada, but who cares, nobody uses that. And then Java. And Java's in the top 5 most efficient languages, right? Doing quite well. Let's just round up, simple numbers, okay? Simple numbers, 2. I'm gonna round up. Keep it easy math, 2.0, okay? So we can say Java is twice as inefficient as C, or to put it another way, C is twice as efficient as Java. Great. Okay, moving on. See some other contenders in the list. You've got C#, you've got Go, Away, you've got JavaScript, and I don't understand this at all. How is this? What's happening there? I thought one compiled into the other. I don't understand this at all, not one bit. Then you've got Nope, moving on. Then you've got this. JRuby is like 30% more efficient than the Ruby interpreter. JRuby is the Ruby interpreter on the JVM. Ruby is the Ruby interpreter in C. The one in the JVM is 30% more efficient, roughly, than the C version. That's how good the JVM is. It's really, really quite good. And then we've got this one. Python. I love Python. This makes me really sad. I've been using Python since the 90s. Bill Clinton was president when I started learning Python. This makes me super sad. Again, let's round up, okay? 76, simple math. I'm not great with math, so let's ask Python to help me here, okay? What did we say? It's 76 divided by 2. So let's say you have a program, and that program uses electricity, and that electricity comes from like a plant, and then that plant creates outputs that are pollutants that are gonna create carbon in the atmosphere, and let's say that that carbon ends up killing one tree. The same program would kill 38 trees if it was in Python. That's a forest. It's a forest. We need to have a conversation about this. It's not great at all for anything. Seriously, it's like Bitcoin mining. It's just bad, right? So I don't know what we're gonna do about that, but it makes me a little nervous. Moving on. So I like Java, okay? I really do. Java's amazing, but I do believe it is amazing for a couple of reasons. One is the garbage collector, right? The garbage collector is fantastic. It allows us to take mediocre code and just sort of get away with it, you know? I love the Java garbage collector. It's an amazing piece of technology. I do, however, take issue with the notion that it is the original Java garbage collector. I think that honor, most assuredly, goes to her. Her name is Jesselyn. She lives in New York City. She is from the island of Java, Indonesia, and she is a Java garbage collector, okay? That's fair. It's fair. I think that's fair. She should be called the original Java garbage collector. By the way, look at that. 20,000 likes. I didn't know there were enough people that would get the joke and find the tweet, but it did. Good. The internet's not terrible all the time, just most of the time. So that's the first thing. Second thing is the just-in-time compiler is fantastic. The just-in-time compiler takes our code and it finds frequently accessed code paths and adaptively turns it into native code, right? The result is really, really efficient binaries that actually perform quite well, even though they're interpreted for most of the code, right? But it has trouble. The just-in-time compiler has trouble with things like reflection, serialization, JDK proxies. I still spelled it wrong. Please don't tell anybody this. This is awkward. Never live it down. At least I'm not using Java 8 in production. This one, JDK proxies, what else? JNI, resource loading, this kind of stuff that risks making variant, the type system, all that kind of stuff frustrates the just-in-time compiler. And still, it does a good job, but it has to work around these limitations. But that said, the results are quite amazing. So what if we could have something that proactively turned the whole thing into native code, right? And obviously, that's a good idea. That's called AOT. So instead of just-in-time compilation, we have ahead-of-time compilation. And obviously, that's GraalVM these days, right? GraalVM does a great job. And it's a great project, and I like it. So let's go ahead and use that. We want to use it, but remember, we have the same problem. It also gets frustrated by these dynamic things. So you have to provide configuration to tell it where something's going to go wrong, okay? And the normal way that people can feed this configuration in is via JSON files. I have two problems with this. First, I hate the word JSON, okay? Now, it just sounds stupid coming out of my mouth. Whenever somebody else says it to me, I laugh and giggle, and it sounds like I'm being rude, but it just sounds like a dumb word. So I speak French. In French, you say JSON, which sounds much cooler. I think we can agree. Much cooler. You can have a respectable conversation about a JSON. But JSON? No, not good. I was just in Taiwan, and there they have Jingsong, which means happiness in the Hokkien language, right? That sounds better. So JSON or Jingsong. But either way, none of this JSON nonsense. It's irritating. So that's the first part. The second part is there's a lot of it required. Think about all the places in your code base where you're going to have these dynamic things that you need to account for. I don't want to do that. I don't have the time for it. Well, Spring Boot 3 introduces a new AOT engine, and it'll do that for us, okay? So we're going to use that. I'm going to go here, go to my build. I'm going to do a Gradle native compile, okay? And we're going to let that run. And if you saw the keynote, you know I hate this part. It takes long enough that I get bored, right? It's long enough, actually, that there's not enough time for me to do anything interesting. It's not like I can go take a walk or fire off an email or something like that, but there is also so long a time that I just kind of sit there and I get bored. And I end up finding myself hand in head, just waiting and waiting and waiting and waiting. And I finally understand this XKCD cartoon. The #1 programmer excuse for legitimately slacking off, my code is compiling. I thought that was just for the C++ people. I didn't know it was us. Here we are, 2023 is a weird year. And I hate the waiting, and eventually I just start to hear like elevator music, in my head. And I went to Oracle and I said, Oracle, would you please play elevator music so that everybody else hears the native image, hears the elevator music as well? And I got some great responses. I said, I already hear elevator music in my head while I do these sometimes long-running compilations. I just like everybody else to hear it too. And I got this response from this fella. This is Andrew Din. He's part of the OpenJDK project at Red Hat, our friends over at Red Hat, a distinguished engineer, Byteman project lead. And he says he wants to use, nope, stop it. He wants to use this one. This is the GoldenEye video game. I thought that would be good elevator music. I got this other response saying that beeps would be very good. I quite like that idea. My stupid rice cooker will beep when it's done. Why can't my compiler? Makes a lot of sense. And then I got this response from Fabio Niephaus, who suggested that he said, thanks for the request, but it would only fix the symptoms, and we're trying to fix the cause. He then continues, but I am working on a -- Josh Long mode. And so that's this. Now I still want this to happen, so please vote this issue up. Basically, you would say native image, -- Josh Long mode. You get the ASCII art, you'd hear the music, and then of course, you have that, right? Good stuff. Something to look at. I'm a fan. Okay, I'm sure it'll get merged. Moving on, let's see. I don't even know what we're doing. Oh, right. Yeah, okay, so it finished about a minute. Okay, there's the application. It's gonna fail because the port's already being used. That's fair. So we're gonna go here and just stop it. Okay, still gonna fail. Remember, I don't have a data source set up. I'm using Testcontainers, right? Git clone run. So this is my production build. I need to have that. I'll go here. I've got this Docker compose file that I've got stashed on the side here. It's gonna run a Docker image for Postgres for me, okay? And I've got this little script here that is gonna set up some environment variables and then run the binary in the service. I'll say run, okay? There we go. The application's up and running in 0.14 seconds. And much more importantly, let's see, where's the PID? There's that, ORSS, that's the resident set size. It's taking about 113 megs of RAM, which is a good deal. I don't know how much RAM your application is taking, but I'll bet Slack is taking 10 times this much on your machine right now, at least, okay? Good, so now we have a service. We got some time. Let's try and do something else. Let's go here and build a client. Okay, I'm gonna call this client, again, great with names. We'll use the reactive web support. We're gonna use Spring Cloud Gateway, and I guess that's enough. Oh, GraalVM, of course, dev tools. And we're gonna build something that's gonna be the first port of call for requests intended for the downstream service. We'll start that up. And what I want to do here is I want to build something that's just the thing that, it's a backend for a front end, it's a API gateway, it's a edge service, whatever it is, it's going to be the thing through which all traffic flows before it goes to my downstream microservice. And so this makes it a natural place to address cross-cutting kinds of concerns. I might do that with an API gateway like Spring Cloud Gateway, right? So I'll use that. And this is great, it's just like Nginx or something like that, right? So I can create a route predicate. I'm going to describe how to match incoming requests, and once they're matched, I'll forward them on to the downstream service, right? But the problem is, I'm trying to match a request with a path of proxy and send it on to the localhost customer's endpoint. I need to act on the incoming request to swap out the path. So I'm going to say, when the path is proxy, swap it out and make it customers, and then I'll just do that, okay? So that's pretty good. That gives me some connectivity from the outside to the back-end services. Let's try that out. Localhost 9999. And then we go here, I'm going to say proxy, okay? These filters are really where all the power in Spring Cloud Gateway lay, though. I can do things like, let's say I want to add CORS headers, add response headers, HTTP headers, .access control origin, okay? Or I can do retries, in case something goes wrong, or I can do a rate limiting, right? I can do that, or I can do a JSON to gRPC. I can do circuit breakers, all sorts of interesting things you can do here, but really I think I'm happy with those selections. Let's just leave those there, okay? So now if I go here, curl minus v, you get that. You can see we've added the access control out origin header. Great. Okay, this is the one thing I might do. The next thing, maybe I want to, instead of just having something that acts generically on the envelope of the request, instead maybe I want to act on the payload of the request. And to that end, I could build a client. I could say customer HTTP client, and I could inject the reactive non-blocking HTTP client like that. And I could do the thing where I create like a method here that returns customer. I can make a network call and all this stuff. There's a couple of problems. First of all, this type doesn't exist on my class path. So I have to create it. So, yeah, I'm not going to do that. I'm going to do something terrible, something that you should never, ever do, ever. Not even when you're all by yourself at home and no one is looking. I'm going to copy and paste some code. So we'll go here. Take this. Okay, here we are, my type, thank you. Put that in there. Great, so that's a little bit better. I've got my type on the local class path, but it still sounds suspiciously like work, and I don't want to do that. So there's a new feature in Spring Framework 6 and Spring Boot 3 and later called generic clients. So I'll just add that, okay? And now I've got this interface. I'm going to provide a mapping for the method, okay? I'm going to say, when somebody injects this proxy and invokes these methods, call the host and port, call the host that we'll specify in a minute and use this path to make that call. So let's do that. Let's now create we're going to use this mechanism to create a factory instance of that interface. I will tell you right now, this will get better. We're working on this. This is a little tedious at the moment. It's not that bad actually, but it would be better if we didn't have to do it at all. So that's what's happening, okay? But in the meantime, we're going to create a web client adapter for this client. I'm going to build the web client like this. Base URL is HTTP localhost 8080.build create client customer.class. Okay, so now I've got a bean that I can inject. Well, what might I do? Well, I can inject that when the application starts up. I can use it to call the downstream service, perhaps like that. http.customers.subscribe and just print out the results. Let's try that out. Command Shift F9, rename HTTP. Okay, let's see here. Unexpected, What did I do wrong? Flux of customer, customer's name. I feel like we should be on the same page here. Unexpected. Oh, friends. Get exchange. Even I make that mistake. This is the client-side peer to these new annotations. Don't use the server-side ones. You can use some server-side ones like this, but not that, okay? So there it is. There, it's worked. Great. So now we have the client. What can I do with that client? Well, the whole point here is to build a view of the data to support some particular use case that isn't otherwise well served by what I've already given them. Imagine you're building an Android device or an iPhone device and a client, and you have 10 different microservices. The last thing that you want to do is make 10 different network calls to 10 different microservices and sort of compose everything in the client code itself. So instead, it's better to do all that stuff here on the server side at the edge. So we're going to create a view of the data, and the way we're going to do that is by using GraphQL. How many of you have used GraphQL before? It's neat. It was created by Facebook, now Meta, back in 2012. So I'm going to say, well, first of all, did I actually specify GraphQL? Uh-oh. I forgot to do the thing. Let's see here. Copy all that. Go back to the build. Paste. Hope. Okay, and we go here. Source main resources, create a folder called GraphQL. Create a schema file. You can call it whatever you want. I'm going to call it schema.graphqls. And then you describe your types, right? This is one of those things I love about GraphQL. Types are required. They're a schema, which is nice. Imagine all the work and pain that we go through to graft schema onto HTTP and REST and the like. In GraphQL, you have 3 verbs, right? You have queries for request response. You have subscriptions for streaming. And you have mutations for everything else, update, delete, add, etc. So I'm going to create a type, a well-known special type called query, and it's off of this that these attributes will be sort of exported as endpoints, right? So I'm going to say there's a field called customers and another one called customers by name, and it'll take a parameter of type string. It's going to return a collection, that's what the bracket syntax is, of customers, okay? So there's my simple syntax. I'm going to go here, I'll say controller, class customer GraphQL controller. I'm going to inject the customer HTTP client, like that, voila. And I'm going to create a query mapping method, okay? So I'm just going to map this method to the endpoint, to the schema for query, right? The field in the type called query. So this.http.customers, voila. And I'll do the same thing here for customers by name, like so. Argument, string name, okay? So there we go. I've got these two different endpoints. Query mapping is a meta annotation, right? It in turn uses schema mapping and defaults the type to query. So it enjoys the same kind of relationship as request mapping and get mapping do, for example, okay? But in the GraphQL context. Okay, now this is all very well and good, but I want to try it out. So I'll go to my property file and I'll say enable the graphical console here. So I'll do that, okay? Now I can go here, localhost. Oh, do I have to restart? I probably do, don't I? Because I added the type. Sadness, hurry up. Okay. 9999 graphical. Okay, wait for it to download the JavaScript. Okay, there we go. So I've got this nice console. I'm going to do a query. I'll get the customers, I'll get the ID and the name, voila. Okay, so there's all the data, but what if I want to simplify things? Well, remember, I don't want to call 10 different endpoints. Maybe I also want to get the customers by name, like that. ID, name, okay? So now I'm getting the customers by name. Oh, I didn't have the customers by name method is actually just using, it's not doing anything useful. Customers by name, passing in that, shift 9. Okay, so now refresh, there you go. So now I've got customers by name and customers, okay? So I've got I'm able to make both calls with one network request. I'm not making multiple chatty round-trip network calls to the API. This makes it much easier to build something more efficient, okay? But what if I want to introduce another microservice? I don't have another microservice, and while we do have 2 minutes and a half to spare, I don't think I have enough time to build another microservice without thinking about what I wanted to build. But let's suppose I did. Let's suppose I had another microservice that had a social media profile type. Well, the backend customer doesn't have a profile at all, but I want to introduce that into the schema. So I'll say type profile, ID, okay? And I'm going to say the schema has a profile. So I'll say profile, okay? Now I want to add a resolver, another method that will get called when that profile is required for a given customer. So I'll do that. I'll say profile, and I'm going to inject the root of the aggregate, the customer. I'll say return a new profile, and this time, let's just say it's the, I'm just going to create it by memory. So getting profile for customer.id, Command Shift F10 or F9, there you go. So now, refresh the page, great. I go here, profile, ID. And when I do that, you can see on the console, it's making a call to that method every single time. That's the n+1 problem, right? That's not great. And if you added some time here, you would see it's actually doing it serially as well. So if you have 1 second of latency, imagine this is actually a network call HTTP profile service, right? Imagine it's actually doing something like that. If you add real latency, you'd see that that adds up in a serial way. You could make it concurrent by using reactive types, but with GraphQL, another option is to instead use batch mapping. And the contract there is one customer, one profile, okay? So imagine, and then you get a list of all the customers that need profiles. So now you can do a batch call to some other backend service, right? So the idea is var map equals new hash map, okay, customer profile for var c customer map.put new profile c.id, okay, return map, okay? So I can say return getting all customers, okay, very good, return. And then I can do that, go here, and you can see it didn't make n+1 calls. It just made that one call. So now I've got the best of both worlds. I've got 2 different microservices. I made just 2 calls to get all the data. I avoided the n+1. And I've got a service that I can then compile and turn into a native image and go to production with. My friends, we're just about out of time. Who learned something new? Who learned something new? Very good. Something in that smorgasbord of Spring. Who had fun? Good stuff. Thank you so much for being here. We're so grateful for all of you. Have a great show.